All right, well, happy Friday, end of our second week, and we'll talk about functions today. Okay, function writing strategies. Now, you guys have already been writing functions. You've had to write functions for homework 1, and then in homework 2, which I just posted, you have to write more functions there. Okay, and so I wanted to talk about strategies for writing functions because at least in homework 2, I think the functions get more complicated, right? And so you want to you don't want to just jump in and start writing a function. You want to kind of think about how you're going to go about this. You want to be able to take that big task and break it down into smaller tasks and build up from there. Okay, so let's talk about that. Okay, so a lot of this stuff comes from. These are just some, I guess, related reading. You have basics about writing functions in the book Introduction to Scientific Programming and Simulation Using R, as well as the Advanced R textbook with the chapter on functions there. All right, so we'll start off with just talking about function basics. You guys already are familiar with the basics of functions, but just kind of review it and go over it. All right, and so, functions, when we write them in R, they kind of have this basic form where we use the keyword function to kind of indicate to R that we're creating a function. You put in any of your argument names inside the body of the function, and enclosed in those curly braces, you have your different expressions where you're doing different kinds of either comparisons or assignment operators or math calculations or something. And at the very end of the function, you return some kind of object. Okay, return some kind of output. A couple things, or I guess quirks that we have, is that if the function in R has only one line, you can technically leave off the curly braces and R will still be able to interpret it. Generally not recommended. It's not good style, but it won't crash your code or something like that. And if you don't use the function return inside your function, that command there, then R is going to take whatever last line of last expression evaluated and return that. So here I could create a function called f where I do x times x, function of x, and you take x and you multiply by itself, and that's a function. Functions are objects. You can kind of treat them as objects, meaning you can put them inside lists and things like that. So I can say, hey, make a list where f is there. Now it says, yeah, you've got a list, and the object inside, basically the first train car, is function of x, okay? And you have that. When you ask type of on what it's a function, R says it's a closure. If you ask mode, R says it's a function. These are kind of like weird words that R uses. This is just part of the R vocabulary. This is kind of what allows, I guess, R allows for, I guess, functional programming. We won't worry about it right now. Okay. A function returns values, and we can use kind of the command use return and explicitly return a value, and we can say this is the value I want to return x times x, or you can just have x times x, and if you don't explicitly use return, then R will just return the kind of last line inside the function. And this is actually the recommended style when coding in R, is not to use return explicitly, but to use x times x. Now, like in Python, you have to use return. If you don't use return, basically your function returns none and stuff like that. So I often use return, but a lot of times as you read other people's code in R, you'll see the return being left off. So I'm not really a stickler on like the style here. So whether you use return explicitly or implicitly, I'm okay with it, okay? One thing to remember is that in R, functions can only return one object. But there's lots of times where you want to return multiple values. Well, you can do that. You just have to group all of those different values into one single object. So, you can do that with either a vector or a list. So here, I want to return 3 values here, x, x squared, and x cubed. And I'm going to do that by kind of grouping them together, combining them into a single vector. And when I run function on 2, I get the 3 values back. They're inside this vector. Here I have the 3 values, but this time they're in a list, and those values have names now. So I have function 2. This returns a list. Again, last line in the code without a return. Even though I don't have a return, this is what gets returned. So I get the values 2, 4, and 8, but now they come with names here. When you define a function and you put in the argument names, here you are also defining the names of the arguments. So here when I say create a function f with arguments x, y, and z, these are the names of the arguments that the function is going to use. And when you call the function and you want to actually use the function, you have to use those argument names as well. If you don't specify the argument names, then R says, okay, well, you're providing me some values. I'm going to assign them in the order that I see them. So here, a very, very simple function, f, and it just takes the values x, y, and z, and then it basically pastes them together into one string or one character, character value, x equals x, y equals y, z equals z. And so if I plug in 1, 2, and 3, it says x equals 1, y is 2, and z is equal to 3. Okay. When you call the function, you can specify the argument names, and when you do that, you can put the argument names in any order you want. So I have z equal 1 equals x equal 2, y equal 3, and again, the function prints out x is this, y is this, and z is that. And so we get x is 2, y is 3, and z is 1, because I put them in that order. If you specify names for some of the arguments, but not all of them, R tries to do its best as far as matching them up. But if you also give the name of an argument that's not part of the function definition, then R is going to give you an error and says it's an unused argument. So here I have y equals 2, but then I just provide 1 and 3. So R says, okay, well, that 1's going to go to x and the 3 is going to go to z. Here I have y is 2, and I give it 1, and x is 3. And again, R tries to match this up and says, okay, well, x is 3, y is 2, and then that leftover argument is going to be z, and it does that. And then here I have 1, 2, 3, m equals 1, and then R goes, whoa, I'm confused, okay? In the function definition, excuse me. In the function definition, I don't have an argument m, so I don't know what to do. Unused argument m equals 1. You got to, if you use an argument inside the function, you got to provide values for it. Otherwise, R is going to complain. So here, I have a function. This function takes in the arguments x, y, z, and w. But as far as the code inside the function, it says paste 0 this, and inside this code I only use x, y, and z. So I can call the function with 1, 2, 3, 4, okay? X is 1, y is 2, z is 3, and w is 4. And even though 4 is not used inside the code here, w equals 4 is not used inside the code here, this doesn't provide an error because this 4 gets assigned to the name w, and that's fine. R just uses those things and doesn't complain. Here I can call the function without providing a w, just f of 1, 2, 3, even though the function takes in x, y, z, and w. But also, R doesn't complain because it says, oh yeah, I was able to do all the lines inside the function. I never needed w, so you never gave me a w, but that's okay. I never needed it in the first place. All right, so this works. However, if I do something like this, here's my function again, and I call it with x is 1, y is 2, and w is 4, and I don't provide it with a z, okay, now R says, well, I can't run this because inside the function I need a value for z, and z is missing, and I don't have a default value. So if you're using an argument inside there, you need to have a value provided for it. But if you don't use it, then R is not going to complain. So to kind of avoid this error of not having a value, you can provide default values. And so I've got x is 1, y is 1, z is 1. This is how we provide default values. And so inside the definition of the function, these are the default values if values are not provided when I call it. And so here I call f with no values, and so r is going to use the defaults. Okay. Here I call f with the number 2, and so 2 gets plugged into the first argument x, and we get that. It uses defaults for the others. Here I call f with z equal to 3, so 3 gets plugged in for z, and it uses the defaults for x and y. That's no surprise, I think. I think we're accustomed to this. Okay, let me give you your first view quiz answer, which is the letter C. C as in cat, C. All right, one thing to remember is that values that are created inside a function only exist inside the function. In general, you should not try to change values in the global environment while you're inside a function. And if you do want to get values from inside the function out into the global environment so you can use it later or something, that value needs to be part of the object returned by the function. That should really only be the way to get things in and out of the function. Values go in through the arguments, and then values come out through the returned object. Later on, I'll talk about changing things in the global environment from inside the function, but again, generally not the recommended style for writing things in R. Okay, so here's an example. We've assigned the value 10 to x in the global environment. We have this function f. Inside the function f, we take in the argument x, and inside the function f, we assign the value x plus 55 to x. So we change the value of x inside the function to x plus 55. And then we're going to return the value x at the end of the function. So when I call f of x, remember we start off with x equal to 10. This function returns 65 because we do 10 plus 55. We assign that back, and the function f returns that new value, 65. But the value in the global environment remains unchanged, stays at 10. So again, x in the global environment is 10. I run f of x. It returns 65. But again, this, even though inside the function we're changing x, it doesn't affect the x in the global environment. X in the global environment remains 10. If I do want to change the value in the global environment, I have to use that function and then assign stuff back to x. So I have to take like f of x, assign it back to x. And in that case, x becomes 65, right? But if I don't do that, the values just remain what they are. We're not gonna change things, okay? Functions are intended to make our life easier. And the goal of our function is to be able to kind of take a chunk of code and be able to reuse it and adapt it for different kinds of values. So as you write code, you're going to find yourself doing the same thing multiple times, right? This is kind of a very common thing. You say like, okay, here I wrote all of these lines of code, and it takes this data frame and it produces this graph using column number 2. And you say, well, you know what? I actually want to produce the same graph, but this time for column number 3. So what do? You often just take that chunk of code. You say, well, this worked well. I'm going to copy it. You paste it. You change all the 2's to 3's, and now that code works for column number 3. And you go, okay, great. And you go, oh, you know what? Let's also do it for column number 5. So you take that code, you copy it, and you paste it. You change the 3's, you change them to 5's, and now it works for column number 5. So that's like a very common thing that you do, where you say, all right, here's a chunk of code. I want to do the same thing again, but I want to adapt it for a slightly different situation. And so that's fine. And my rule of thumb is this. You copy and you paste it once, no biggie, okay? If you copy and paste it a second time, okay? So basically you have the same chunk of code existing in 3 places now. You should really start to think about a function, okay? And by the time you copy and paste it a 3rd time, so you're gonna have the same basically chunk of code but in 4 places, definitely it should be a function at that point, okay? You don't wanna have the same chunk of code existing in 4 places or more than that, okay? So kind of my upper limit is copy and paste once, fine. Copy and paste twice, then it's like, maybe you should have a function. By the time you do it, by the time you copy it a 3rd time or paste it a 3rd time, you basically have the same chunk of code 4 places, that's when you should say, this needs to be a function, okay? And the reason for that is because let's say later on, you're like, oh, okay, I like the way this graph looks, but you know what? I actually want to change the thickness of the line. I want to go from line thickness 1 to line thickness 2 or something like that, right? And if you have the same code existing in 4 places, now you have to modify line thickness to 2 in 4 different places or more, okay? And if you forget to do it in all of the places, then you start getting like slightly different variants of stuff, and it's just not great. If you have it in a function, you just change it in one location, and every time you execute that function, it's gonna work. Okay, so that's why we want to do a function, right? If you're gonna again copy and paste the code multiple times. Again, which is a very, very common thing to do. You don't ever have to feel bad about copying and pasting your own lines of code to just repeat the same task, because that's what coding is. It's like repeating the same task but just in slightly different situations. But then we should be using functions. Okay. When you name your functions, it should be clear what the function is doing. All right. In all of these examples, I'm using terrible, terrible names. I'm calling my function f, f2. These are like the worst possible names you can name a function, okay? If your function is going to draw a board, like in homework 2, you have to draw a chutes and ladders board, you know, the function should be called draw board or something like that, right? It should be clear what the purpose of this function is doing, okay? Sometimes your functions return true or false values, okay? Because you want to check for some kind of condition or something like that. And in that case, the function should be kind of phrased into like a yes or no type question. So for example, is a number a prime number? You should call your function is prime, okay? Is prime kind of clues to the user that this is going to return like a yes or no answer, a true or false value, okay? So you can say, is prime 7? True. Is prime 9? False, right? And then, and that way you can also put that inside an if statement, right? And you can do if is prime x, then do this, okay? And this is one thing that I always kind of annoys me a tiny bit, is when I see students putting inside an if statement, if is prime equals true or something like that. There's no point in doing equals true inside an if statement, right? Because either it's true or it's false. And so it's going to be if true, then it's going to do it. If false, it's not going to execute it. You don't need to do if true equals true, all right? That's redundant, okay? So just do if is prime x and so on and so forth, okay? And so again, functions are supposed to make your life easier. If you find yourself in a situation where you've written a whole bunch of functions and you can't keep track of them in your head or whatever, you've probably done something wrong, okay? The point of the functions is to make your life easier, not make it more complicated. So they should be simple enough to be kind of quickly understood. All right, let's talk about some function writing strategies. And let me go ahead and give you your second view quiz answer. It's the letter B. B as in bear. B as in bear. Okay, so I'm going to work through coding up a sorting algorithm. This sorting algorithm is called bubble sort. It's not the most efficient sorting algorithm. There's a lot of sorting algorithms that are much faster and much more efficient, but this is very simple. And it was necessary and useful in a time where there was very kind of limited computer memory. So if you go back 60 years, you know, the early computers were only able to kind of store so much information in their things, okay? Maybe or 50 years or whatever. And so you had to kind of write code that was memory efficient. Now you buy a laptop and it's got 16 gigabytes of RAM, or I don't know, your phone. How many gigabytes of RAM does your phone have? It's incredible, really. Probably your refrigerator has more memory now than a bunch of things. Okay, so but anyway, the way bubble sort works is it just looks at two numbers at a time. So as far as the memory requirements in the computer, it just needed to be able to store two numbers at a time. And so it just looks at these two numbers, it compares them. If they're in the correct order, it moves on. If they're not in the correct order, it swaps positions. So if you want to sort from least to greatest, correct order means the number on the left is smaller than the number on the right. Incorrect order would be the number on the left is bigger than the number on the right, and we want to swap those so that the one on the left is always bigger than the one on the right. And then you do that, and you perform one sweep, and then you do it again, and you keep performing sweeps. And as you do this, basically, with each sweep, the biggest number kind of rises to the top or gets pushed all the way to the right. Okay, and that's kind of why it's called bubble sort, is because it's like bubbles rising to the top, and that the biggest number each time with each sweep rises to the top or gets pushed all the way to the right. So here's a vector 5, 1, 8, 2, 4, and we're going to run bubble swap. And so we start by looking at the first two numbers, 5 and 1, and we say, is that in the correct order? They're not. 5 is bigger than 1, and we need it to go to the right. So we're going to swap the position of those two numbers. So after we swap the position, now we are at 1, 5, 8, 2, 4. And then we move to the next pair. We look at 5 and 8. Is that in the correct order? They are. So we don't swap. Then we compare 8 and 2. Is that in the correct order? They are not. So we swap the 2 and the 8. 8 gets pushed over to the right. Then we look at the 8 and the 4. Are they in the correct order? They are not. So we swap. So now the 8 has been pushed all the way to the right. Then, we will lock that 8 into the kind of final position, and we just repeat the process again. 1 and 5, is that in the correct order? They are, so we don't swap. Then we move to the next pair, 5 and 2. Is that in the correct order? They are not, so we swap them. Then we look at the 5 and the 4. Is that in the correct order? They are not, so we swap them again. Okay, and so now the 5 is in the correct position. Okay, technically our vector is in order, but we don't know that yet. The algorithm doesn't know this. So, but we do know that 5 and 8 are in the correct position because we've run the sweep twice, so we know the last two values have to be in the correct position. So we look at the 1 and 2. Do we need to swap those? We don't. We look at the next two, 2 and 4. Do we need to swap those? We don't. So we now know the 4 is in the correct position, or the third from the right. And then we look at the last two, 1, 2. Is that in the correct order? They are, so we don't need to swap. And so now we know that all of the values are in the correct order. Okay, and so our vector is in order 1, 2, 4, 5, and 8. There's a little GIF here animating bubble sort, and let me pull that up here. It's on Wikipedia. And so here we start off 6, 5, 3, 1, 8, 7, 2, 4, and we compared the 6 and the 5. They were not in the correct order, so we swapped them. Now we compared the 6 and the 3. They're not in the correct order, so we swap those positions. We keep going. 6 and the 1, not in the correct order, so we swap. The animation takes a little while. 6 and the 8, they are in the correct order, so it moves on. What about the 8 and the 7? They are not in the correct order, so it swaps the 7 and the 8. What about the 8 and the 2? It swaps those positions. And then the 8 and the 4, it also swaps those. And so with one sweep, we now know that the 8 is now in the correct position. The largest value is all the way to the right, and it locks into position. Then we repeat 5 and 3, and we need to swap those. Okay, 5 and 1, we need to swap those. Come on, okay. And then we go to the 5 and 6. That's in the correct order, so that's okay. 6 and the 7, that's in the correct order, so that's okay. And so now we're going to look at 7 and 2, and we swap that position. And then we look at the 7 and the 4, and we swap that. And so after two sweeps, we now know that the right two most values are in the correct position. And then we kind of repeat this over and over, and with each sweep, we know one more value is in the correct position all the way to the right, okay? And so we don't have to watch this whole animation go through, but that's what we want to do. And so now we want to say, okay, how can we code this? How can we code this, okay? So we're going to try to break down our function, the tasks, or the function into smaller tasks, okay? And this is a key idea that you need to be able to, that you want to develop as a programmer, as someone who's going to be writing code. You're frequently going to be faced with this big thing, and you need to break it down into smaller tasks. I mean, really, that's all of life, right? Like, planning a party or whatever, right? You just say, okay, well, let's break this down into smaller things, okay? And then you do each of the little smaller things, and sometimes you delegate the smaller tasks to someone else. But anyway, we're going to take something like this, break it down into smaller tasks. Now, there's going to be lots of ways for a lot of different tasks or a lot of different functions. There's probably going to be multiple ways to break down a task into smaller things, and that's okay. That's okay. But so here's one way that I'm going to break this down. Is as far as the bubble sort algorithm, one of the smaller tasks is just taking two numbers, comparing them, and swapping them, okay? So that's one of the tasks we need to be able to do, all right? So that's like compare the adjacent values, swap the adjacent values, okay? And then the other task we need to do is we have to do that thing of swapping values and perform it multiple times. We need to perform a sweep across the entire vector, and then we need to perform multiple sweeps, right? So once we can do it across the entire vector, we want to say, all right, let's do this again and again and again so that the entire vector is sorted. Okay. When we write a function, okay, what you do not want to do is you do not want to start writing the function right away, all right? So maybe some of you guys did this during homework 1, but as you kind of move forward, the first thing you don't want to do is you don't want to write function x and curly braces, okay? Because that's going to just make your life harder as far as like trying to debug your code. Because when you write a function, you're probably not going to get it right the first time around, and you need to be able to debug it. And again, when you write things inside a function, the values inside that function only exist for the duration of the function running. It only exists inside the function, and so when the function quits, those values poof and disappear. Now there are ways to figure out what were the values inside the function. You can run the debugger and things like that, and it kind of pauses the code right in the middle of execution, and you can kind of explore things. But you can kind of avoid all of that just by kind of working directly in the global environment. All right, and when you work in the global environment, all of your values are there and they exist, and you can kind of just see, is this kind of proof of concept? Are these lines of code even working in the first place? And then you can kind of figure it out, right? So let's just start off with the very first task of like, can we just swap two values, okay? So if I have the vector, can I just swap the values in position 1 and position 2? So if I have 5, 4, 3, 2, 1, can I do that so I get 4, 5, 3, 2, 1, okay? And I guess implicitly here, I didn't actually write this on the slide, but another thing that you need to do as you're writing code is you want to check if the line of code you wrote does what you expect it to do, okay? So you should always say like, this is, if I start off here and I run this line of code, what do I expect it to do, right? What I'm expecting it to do is go from 5, 4, 3, 2, 1 to 4, 5, 3, 2, 1. Okay, I'm not expecting it to have it fully sorted. I just want to be able to swap these first two values. So I have an expectation. I expect to see 4, 5, 3, 2, 1. And then I run whatever line of code I wrote, and I want to see, did I get what I expect? 4, 5, 3, 2, 1. So let's say I just decide to write a function. I dive into it and I write a function. Again, this is not the recommended way. So I say, all right, I want to swap their first two values. So I'm going to take x position 2, put it into x position 1. And then I'm going to take x position 1 and put it into x position 2, okay? And then let's return x. And so what happens when I run this? So I start off with x, 5, 4, 3, 2, 1. What I want to see after I run this code is 4, 5, 3, 2, 1. But when I run it, what do I get? I get 4, 4, 3, 2, 1. 4, 4, 3, 2, 1. So again, at least I've done something right here in that I checked immediately to see if I got what I expected, and I didn't. So now I know something is wrong, okay? Sometimes students come to me in office hours, and please do come to me in office hours if you are stuck and in trouble. I don't want you to feel intimidated. But when sometimes students come to me in office hours and they have a whole bunch of lines of code written, and they say, my function's not working. But like very early on, I'll spot an error, like in the first couple lines of code, and I say, hey, did you check to see if this first or second line of code does what you expect it to do? And they'll say, oh, I never bothered to check, okay? So again, every single line of code you want to kind of just check and make sure, is this line doing what I expect it to be doing, right? And so here, I just wanted to see, hey, did I swap 5 and 4 to get 4, 5, 3, 2, 1? And I didn't. I got 4, 4, 3, 2, 1. Again, the problem here is I've written it inside a function, so I can't really see what went wrong. So what I recommend, don't write a function. Just start in the global environment and see if you can kind of swap this. And so here, I'm going to just kind of delete everything in the global environment. Okay, you can hit the little broom icon. Or if you're writing a script, you can include this little just while you're writing everything. So you don't want to put this line, you don't want to keep this line in the final version of your script, but just as you're writing your script, you can put this little line. This is basically hitting the broom icon. This says remove everything in the global environment, okay? And so when you source your script, it's going to just delete everything. And that just saves you one extra click, right? You can easily hit the broom, delete everything out, but you can also just write this line of code, and this will delete everything in the global environment. But again, don't actually include it in your final line. When you're done with the script, make sure you get rid of this thing, because you don't want your script actually deleting stuff when it's running, but as you're coding it up for the first time. Okay, so anyway, I'm going to just write in the global environment. Let's just see what happens. And we're going to just check, what does X look like after every single line of code? So I start off with X is 5, 4, 3, 2, 1. And then I say, all right, let's take X position 2 and put it into X position 1. And then we say, what does X look like? And it says 4, 4, 3, 2, 1. And now we start to see where things went wrong. And we can see, okay, well, when I try to do X position 1 and put it in X position 2, X position 1 is already 4. And so now I put it into position 2, it just stays 4. And basically, we lost that 5, right? When I wrote this line, X position 2 goes into position 1, I lost the value that was in position 1. It got overwritten. So what I need to do is I need to store that first value somewhere, okay? So again, clear out the global environment. Let's try this again. X is 5, 4, 3, 2, 1. We're going to take the value in X position 1, store it in a temporary location. Then I take X position 2, put it into X position 1. And then I take that temporary value and put it into X position 2. And then I check X, and I have 4, 5, 3, 2, 1. So great, this looks like it works, okay? So I say, all right, well, let's just check these lines of code. Let's try it out somewhere else. Here's another vector, 1, 2, 3, 4, 5, 6, 7, 8. If I run this code, what do I get? It swaps the first two values, 2, 1, 3, 4, 5, 6, 7, 8. Okay, so yes, it does swap the first two values, but I don't actually want to swap the values in this case. I want to have a condition that says check to see if I should swap them in the first place at all. So what do? I'm going to just take that line of code that swaps the first two values, but I'm going to check, is position 1 greater than position 2? If position 1 is greater than 2, then we swap the positions. But if it's not, just leave it as is. So here I have X is 5, 4, 3, 2, 1. In this case, we should swap them, the first two values. And indeed we do. When I run this code, it swaps them. I will get 4, 5, 3, 2, 1. So this is working. Here I have 1, 2, 3, 4, 5. And in this case, we don't want to swap positions for the first two values. And that looks good. Okay, that looks good. So we say, all right, I'm able to compare two values, and I'm able to swap them, at least for positions 1 and 2. Okay, and what I want to do now is not just positions 1 and 2, but also positions 2 and 3, and 3 and 4, and 4 and 5. So we want to kind of perform a sweep across the entire vector. So what I can do is I can say, well, let's make a for loop, all right? And instead of looking at positions 1 and position 2, I will replace all of my 1s with an I and all of the 2s with an I plus 1. And I'm going to put this inside a for loop. So I'm going to say, all right, if you've got a vector of length 5, then let's do for I in sequence length of x. So it's going to go basically for 1 through 5. And then we're going to do, look at x position I and x position I plus 1. Compare those two values. And if we need to, we will do the swap. X position I goes into the temporary position. I plus 1 goes into x position I. The temporary value goes into x position I plus 1. Okay? I just replaced the 1s with i's, the 2s with I plus 1. Okay. There's a problem here with our code. And maybe you can spot it, maybe not. But that's okay. You don't need to be able to spot every single problem right away. You can try the code out and see what happens. So we want to see, all right, will this run? Here I got x54321. Can I run this? And so I try running that code. x54321 for I in sequence length of x. This. But I run into an error. I get error in if x position I greater than x position I plus 1, missing value where true false needed. Okay, when do we get missing value where true false needed? That happens when I get an NA inside my if statement, right? If statements need to be true or false, and here I'm getting an NA. I'm getting a missing value. And really, the only thing that's happening here is I'm comparing x position I and x position I plus 1. So we want to know, what was the value of x position I? What was the value of x position I plus 1? Because I'm working in the global environment, I'm able to check that. If I was working just in a function, then I wouldn't know. Because the function, it's you can't look inside the function. But here we'll ask, what is that? Okay, so I can say, well, what was I in the global environment? It says it's 5. What is x position I? X position I is 5. Okay, that seems okay. What is x position I plus 1? Okay, there we see we get an NA. Okay, because we're asking for what is x in position 6, and our vector x was only length 5. So that makes sense to us. We're getting an NA here, and this is why we have a missing value, and this is why I get the error, missing value where true false needed. So again, the error messages that you get in R point you in the right direction. It tells you where the line of code is, where it went wrong, where you can start looking. Okay. Now, something could have went wrong earlier, but it comes to a head here. But again, it gives you an idea of where you start looking. So we go, oh yeah, you know what? I shouldn't be checking at xi plus 1. I don't want to be looking at position 6. So what I need to do is I just need to adjust my for loop so that if I have 5 numbers, I'm really only doing 4 comparisons. Okay? So how many comparisons do I do? I'm going to do sequence length. My length of x isn't the length that I want isn't length of x, but it's length of x minus 1. Okay? So I'm going to do for I in sequence length of x minus 1. And then I run the code. And when I run the code for 54321, indeed, that 5 gets pushed all the way to the right. And this looks good. This looks good to me. And so let's just try this out again with another vector. So I have a vector 1, 2, 5, 8, 3, 6. And what I want to see is I want to see that 8 get pushed all the way to the right. And indeed, the 8 gets pushed all the way to the right. So that seems good. Okay. Here's just another random sample. Here I have, I just take a vector of length 10, random order. I run the same thing. Again, testing every single time just to kind of make sure things are working. And indeed, the 10 gets pushed all the way to the right. So that looks good. All right, so what we need to do now is we just need to repeat this process and perform multiple sweeps every single time, okay? And every time I do another sweep, I'm going to have kind of one more position locked in place here. So here I can just say, all right, here's my vector. Again, I clear up my environment. X is 54321. And I just have the code. And I run it once. I ask, what is X? 5 has been pushed all the way to the right. I just copied and pasted the code again, just running a second sweep. And this time the 4 gets pushed all the way to the right. Okay, so I can say, oh, you know what? I can just take this chunk and just put it inside another for loop. Just repeat it again and again and again. Okay, so I just need to perform multiple sweeps. How many sweeps do I need to do? It's going to be length of x minus 1. So I just took that for I in sequence length, and I just put it inside another sweep, inside another loop for S, for sweep number 1, sweep number 2. How many sweeps do I need to perform? Length of x minus 1. And I think it works, okay? 5, 4, 3, 2, 1 gets sorted into 1, 2, 3, 4, 5. So that looks good, okay? Technically, there's a little bit of inefficiency because the first time I do the sweep, none of the positions are locked, so I have to kind of go through the entire vector. Or I go up to length of x minus 1. But the second time I perform the sweep, I don't need to go through the entire vector because I know the last value is already locked in the correct position. So I could end one spot early. And when the third time so I can end at position length of x minus 2. The third time I perform it, I can do length of x minus 3. The fourth time, length of x minus 4. I can, how many things I need to kind of swap is shrinks every time I do another sweep. And so I can do that by just kind of adjusting my thing. And so I could say start off with 0 locked values, and then how many comparisons do I need to do? The sequence length is going to be length of x minus 1 minus how many positions are locked. And after every single sweep, I can increment the number of locked values by 1. Okay? So I can just increase my efficiency a little bit by starting to lock in positions. And does it work? 5, 4, 3, 2, 1 does indeed get sorted into 1, 2, 3, 4, 5. And here is 40 random, a vector of length 40 in random order. I run my code, and it gets sorted. Okay, and again, so it's not even a function. It's still just, it's just code written in the global environment, and I'm just running it to see if it works. And it looks like it's working. Okay, and so this looks like it works. So what I'm going to do is I'm going to take this, wrap it inside a function. I'm going to call it bubble sort, function of x. I have all of that stuff, and I say, all right, well, this looks good. Okay, and so let's just take a random vector of 100 values, store it as x, and I call bubble sort x, and nothing happens. So what went wrong? When you look at it, we say, oh, you know what? My function actually isn't returning anything. So all I have to do is just have to add one more line here that just says return x at the very end. Okay, and then now it works, right? So here's 100 vector of length 100 in random order. I call bubble sort, and indeed it sorts it from least to greatest. So that looks great. Okay, so again, to recap, break down your task into smaller things. Don't start writing a function. Just start working in the global environment. Okay, check after every line of code to see if your thing does what you expect it to do. All right, and then when something breaks, look at the values inside the global environment and kind of change things as necessary, right? And then you add to your code incrementally, and every time you make a change, test it out. Test it out to make sure things are working. And that means you have to think about what do you expect to happen, and is it doing what you expect to happen? Okay, let me give you your third view quiz answer. Third answer is A. A as in apple. A as in apple. Okay, a lot of times I recommend writing a little script file, and then what you can do is put in this little line, remove list equals ls, and that's going to clear out your global environment. Again, just do that while you're drafting your script, and then in the final version of your script, you don't want to include that line, okay? And then as you work, you can kind of source it, all right? Or hit Command-Shift-S, Control-Shift-S. That's going to run the code here. And as you encounter problems, okay, you can look in the global environment. Where did something go wrong? Where did something go wrong? Okay, so homework 2 has been posted. I know some of you guys are still wrapping up homework 1. But I want to just talk a little bit about homework 2. And in homework 2, you're gonna write some code to simulate Chutes and Ladders, the children's board game, and one of the tasks is to draw the game board. Okay, and the game board is kind of this grid, rectangular grid. How are you going to do that, right? And it feels a little bit overwhelming, like, oh, where do I even get started? Okay, well, again, just break it down. So when you draw the game board, what do you have to do? Well, you got to draw some lines sideways. You got to draw some lines vertically, right? Like, what do you have to do? So, so let's look at that. So here I'm going to just start by writing plot.new. That creates an empty plot. Nothing happens, okay? And one of the functions we use to draw a line is this function called segments, okay? And in segments, it takes in basically your starting coordinate and your ending coordinate in the xy plane, right? So you give it x0 and y0, that's your starting coordinate, and then x1, y1 is your ending coordinate. So here I can start off at 0, 0, and 10, 10, and I get a diagonal line going from 0, 0 up to 10, 10. So what do I want? I want a horizontal line. And a lot of times, if you're going to draw something, it's really handy to just take a piece of paper and just draw on it, and then and figure out what coordinates you have, right? If you have graph paper, draw on the graph paper. And you say, okay, well, if I want a horizontal line, I'm going to start off at 0, 0. I'm going to go horizontally, so my y value doesn't change, but x is going to end up, we'll say, at 10. So I'm going to go from 0, 0, x0, y0, to x1 is 10, and y1 is 0. Now I get a horizontal line. Okay, great. Okay, now I want to draw a second line. Okay, so let's go up to the next line. All right, and I got x1, y is 1, so I'm going to have 0, 1, end up at 10, 1. Okay, so I have 0, 1, end at 10, 1. And I get a horizontal line. Oh, that's kind of spaced out. All right, what about the third line? Okay, the third line, y is going to be 2. So we got y0, y1, y2. And when I do this, x0 is 0 and y0 is 2. And I go to x1 is 10 and y1 is 2. I don't even see it. I go, what happened here? So as R is drawing, it doesn't know what scale to put y on. It doesn't know what scale to put x on. So here we got to give it a little bit more direction. So after I create a new plot, I'm going to define the edges of my window. I'm going to do plot window, and I'm going to say my x limits are going to go from 0 to 10. My y limits are going to go from 0 to 10. And then I'm going to put in this argument called aspect ratio, okay? And I'm going to say aspect ratio 1. And that means have a 1-to-1 ratio between the x-axis and the y-axis. And that basically makes circles look like circles, okay? Whereas if you didn't have it on the same ratio, then circles would look more like flattened ovals or something like that. Okay, and so here when I do this now, now it looks like what I want. Okay, this first line 0, 0 to 10, 0. The next line at what is this? 0, 1 to 10, 1, and 0, 2 to 10, 2. Okay, which is what I have. And so now I want to draw 11 of these segments. And so rather than having to copy and paste all of these things, I can just write a little loop and do it for y equals 0, y equal 1, y equal 2, all the way up to y equal 10. So I'm going to just have for r and 0 through 10 for each row, draw these things, okay? So we're going to start off with, for all of these, the x coordinate is 0 and the ending coordinate is 10, but the starting and ending coordinate for y is going to be r. And so now I get these horizontal lines, okay? And then now I want to, this is one of those optical illusions. This is a square, but it looks like it's taller, right? But it's an optical illusion. As soon as I put in the horizontal lines, it'll be a square. And then I want to do the same thing, but with vertical lines. And for vertical lines, what is it? I'm going to have the starting x-coordinate is 0. The ending x-coordinate is going to be the same at 0. But the y-coordinate starts at 0 and ends at 10. And then we go to the next one. X-coordinate 1, y-coordinate is 0. X-coordinate remains at 1, but the ending y-coordinate is 10. So I just write another loop for c in 0 through 10. Start off at x0 is equal to c. Y0 starts off at 0. The ending coordinate is at c. Y1 is equal to c, right? So this is the same thing, and now we're just adding vertical things. And so we can see, oh yeah, it's a... All right, and so there you go. There's your grid of lines, and that's just to get you started. All right, you got to figure out how to add more stuff. You're going to have to add little arrows to represent the chutes and the ladders. You're going to have to put little text labels, position, box 1, box 2, box 3, and so on and so forth. And you'll want to kind of just pause and think. Again, start off on pieces of paper, write things out, and say, okay, how do I turn this into like a command, right? How do I write this into code? And so again, take your tasks, break it down into smaller things, and build up. Okay. So that's just to kind of get you started, and you can kind of keep building off of there. All right, that's it for today. I think I've given you all 3 view quiz answers, so we'll end there. Have a great weekend. Good luck as you work on homework 2 or wrap up homework 1, and we'll see you on Monday.